Welcome back again to another fun-filled lesson with Mrs. Trombley. We are still in section 2.1 and now we're in part B. So the second of the third part. We're still talking about rational numbers, those numbers that can be written as a ratio of two integers where the denominator is not 0. Our goal today is to not only be able to write a decimal as a fraction, but we want to be able to write a fraction as a decimal as well. So we're going to be going back and forth. The purpose of this, you'll see in lesson 2.1c, is to be able to order rational numbers on a number line. Values are very important in the real world, and we have to make sure that we understand what's worth the most, what's worth the least, and so on and so forth. So you'll see here from this little chart, place value is going to come back. Yes, I know it's been a while since you have talked about that, but I know that you have. And you've learned all your different places. Let's start with that really quick, just taking a peek at this chart. So place value in decimals. Here's our decimal point, and we use the word and to show the decimal. We don't say 3.25. We would say 3 and 25, and that would be hundredths. So whatever the place is for the last digit is how you would read it. This would be read as 145 and 1068 ten thousandths, because the 8 is in the 10 thousandths place. And this would be read as 24 and 79 thousandths. What's kind of nice is, if you can say it, then you can write it as a fraction. Because when you see thousandths, that means that your denominator is 1,000. When you see hundredths, that means your denominator is 100. If you see 10 thousandths, that means your denominator is 10,000. So understanding place value and being able to say these decimals properly is going to really help you when you're trying to write decimals as fractions. There's other ways to do it too, but that's, I think, the easiest way, and I always want to show you the easiest way first. So what are our steps? Our goal is to be able to write a decimal as a fraction. I have some steps kind of outlined here for you. Number 1, any numbers that are to the left of the decimal point represent the whole number amounts that you have. So if you see that there is a value, to the left of the decimal point other than 0, that's going to be your whole number amount. So for example, for this one I have 3.25 or 3 and 25 hundredths. This 3 represents the whole number amount that we have. So my step 1, I would write down that 3. Step 2, write the digits to the right of the decimal point as the numerator. So the whole number in this one would be 3. The digits to the right of the decimal are 2, 5, so that means that my numerator would be 25. To figure out the denominator, it says write the place value of the last digit as the denominator. So if I know that this last digit 5 is in a hundredths place, that means this would be 25 over 100. Or you can kind of look at it, if you have trouble with place value, and let's say you have misplaced this chart, if there are 2 digits to the right of the decimal point, the number of digits tells you how many zeros after the 1 in your denominator. So I know that this is 25 hundredths because I understand this is a hundredths place, but you could also look at it as 2 digits means 2 zeros. With this one, it would be over a 1 followed by 4 zeros. This would be over a 1 followed by 3 zeros. I, of course, would like you to know place value and do it that way, but that's just a shortcut. Okay, number 4, yep, you have to simplify. Don't even ask. The answer is always yes. You must simplify your answers. So let's try a few here. And you can use the chart to kind of help you throughout it. Okay, so with this first one, if I were to read this properly, I would say -7 tenths, right? If you can read it properly, you can write it, and here's what I mean. -7 tenths means -7 tenths. I know, it's that simple. If you're kind of looking at that like, what? I don't know my place value. This is all kind of a big review for me. Then look at your steps. Number 1 says to write the numbers to the left of the decimal point as the whole number. I see negative, and then I see a 0. This 0 means you don't have a whole number amount. It's nothing. It is important that you know that it's negative, though. So I'm going to bring over that negative sign. That means my value at the end is going to be negative. Step 2 says write the digits to the right of the decimal point as the numerator. So to the right of the decimal point, I have the number 7. That's my numerator. Step 3 says, write the place value of the last digit as the denominator. Well, this 7 is in the tenths place, right? That means my denominator is 10. So either way, whether you set it and it's like, oh, this just clicks for me, or maybe it's been a while since we've talked about place value, maybe you struggled with it in the beginning, you can follow those steps as well. Either way, the answer is -7/10. If you put the negative with the 7, that's okay. You can also just put it right in the middle. It doesn't change the value of it. All right, next one, I have -1 and 125 thousandths. Now some of you just say it and you already know how to write it. For those of you that don't, step 1, write the numbers to the left of the decimal point as your whole number. So that means my whole number is -1. Step 2, write the digits to the right of the decimal point as your numerator. So that would mean my numerator is 125. Step number 3, write the place value of the last digit as the denominator. So here's tenths, hundredths, thousandths. That means my denominator is 1,000. I know. It's okay. Also, if you looked at this, see how there are 3 digits and there are 3 zeros? That could be kind of a little shortcut for you as well if you don't have a place value sheet in front of you. Now, step number 4 says always simplify. So this can definitely be simplified. The -1 is fine. The fraction is the part I need to simplify. So in looking at 125 and 1,000, there are a bunch of numbers that would probably go into both of these, right? I look at that and I see, well, I know 25 would go into both of those. So let's try that. That means I'm going to divide each part, the numerator and the denominator, by 25. So 25 goes into 125. If you're not sure off the top of your head, then you could count by 25s and see how many it takes to get there. 25, that's 1. 50, 75, 100, 125. So it took us 5 25s to get there. That means that 125 divided by 25 is 5. I just said 5 a lot of times. Could you tell? Next, I have 1,000 divided by 25. Maybe you don't want to count all the way up to 1,000 by 25. If you wanted to, if you could do this in your head, if you see a long division problem in your head, then you're saying, well, 25 doesn't go into 1, it doesn't go into 10, it goes into 100 4 times, and then I have a 0 left over, so that would be 5/40ths. I see that it's not simplest form. If some of you are like, how did you just do that? All I did was I took 1,000 divided by 25. And 25 doesn't go into 1, it doesn't go into 10, it does go into 100 4 times. So I'm going to put the 4 above this 0 so that I show it's going into 100. And 4 times 25 is 100. I subtract, bring down my 0. 25 doesn't go into 0, it goes into 0 times, I should say. And that's how I got that. Now, when you look at this, I have -1 and 5/40. We didn't pick the largest number that goes into both. That's all that means, because 5 and 40, 5 goes into both of those as well. So it's just kind of guessing and checking. If you have large numbers as your numerator and your denominator, pick a number that you know goes into both, and then work your way through it. So I'm going to simplify this hopefully one more time, and I know that 5 goes into both of those. So I'm going to bring over that -1. 5 divided by 5 is 1, 40 divided by 5 is 8, and now I'm finally done, because there's not a number other than 1 that goes into 1 and 8. So, voila. All right, next example. I have 3 and 1, and it's in the hundredths place, this one is, so it will be 3 and 1 over 100. If you can just say it, you can write it. If you're not sure, take the digits to the left of the decimal point. Step 1, write that as your whole number. Step 2, write the digits to the right of the decimal point as your numerator. Now, some of you might be tempted to write a 0, then a 1. What's the value of 0, 1? There's not a decimal point. That just means 1. Now, this is where I'd have a lot of people want to write a 10 here. This 1 is not in the tenths place. It's in the hundredths place. And step 3 says you're supposed to write the place value of the last digit as the denominator. So this would be 1 over 100, because this is in the 100ths place. Or 2 digits, 2 zeros. This one's done. There's not a number other than 1 that goes into 1 and 100. Beautiful. All right, next, I have -10 and 25 10/100,000ths. So maybe some of you know right off the bat how to write that because you can say it and you're already simplifying. If not, any digits that you have to the left of the decimal point, that's your whole number. Digits to the right become your numerator. So step 2, write the digits to the right of the decimal point as a numerator. I have 0 to 5. We wouldn't normally write a number as 0 to 5 unless it was as a decimal. So I'm going to drop that 0 and write my 25. And this 5 is in the tenths, hundredths, thousandths place. So it's 25 over 1,000. It wouldn't be 25 over 100 because there are 3 digits to the right of the decimal point. That means 3 zeros. The negative 10 is good, but 25 1,000ths can be simplified. So let's do that. I have negative 10, and 25 does go into both of those. 25 goes into 25, yep, one time. And I think we already divided 1,000 by 25, didn't we? And we figured it out that it was 40. So this would be negative 10 and 1/40. Voila. I wish I could say that we're done, but we are not. We still have one more little set left. Just imagine if I would have kept all these notes in one set, though, right? I broke this up into 3. This would have been a crazy time. Okay, so we know how to write decimals as fractions. Now I want you to be able to write fractions as decimals, so you can kind of go back and forth with them. There are 3 methods that you can use to write a fraction as a decimal. I know, I'm not going to spend time on all 3, but I do want you to know that there are more ways than just the one I'm going to focus on. Number 1, I think, is the easiest one. It's kind of like the other spot where we just wrote down the place value because we could say it like negative 7/10. Oh, that's negative 7 over 10. So number 1, method 1, just look for the benchmark fractions that you know. In class, we went through kind of a list of them that we've been exposed to for a long time, like the fourths. The fourths, I kind of know in my head. I know that 1/4 is 0.25. And I know that 2/4, that's 2 out of 4, that's half, so that's 0.5. And 3/4 is 0.75. So in looking at how, when you have to convert your fractions to decimals, there are some of them that you'll just know. And that's okay. The ones you just know, you can write down. Another way to do this is you can write the fraction as an equivalent fraction with the denominator as a power of 10 and use place value. For example, if I know that a number is out of 10, like 7 over 10, then I know that's 7/10, which is 0.7. If it's 7 over 100, I know that that would be 7/100, so 0.07. So if your denominator is 10 or 100 or 1,000, you can just use that and the place value to go ahead and write it out. Number 3, and this is the one I'm going to focus on, this is the method that works no matter what. You don't even have to have anything memorized. It's very tedious, I will say. But to change a fraction into a decimal, fractions are just little division problems. You just divide the numerator by the denominator. So let's say that this is my numerator, this is my denominator, right? You would take the numerator and divide it by the denominator. And in most cases, we would be using long division because I know it's crazy, but you don't get to use a calculator for the first half of Chapter 2. Not because I'm trying to torture you, but because that's what the state of Michigan says. And I follow the rules. We're rule followers, right? It's what's best. Okay, so we've got 4 of these. Let's knock them out. Write each fraction as a decimal. So I see negative 2 and 1/4. This whole number out here, remember when we were doing the opposite and writing decimals as fractions, the digits that were to the left of the decimal point were the whole number and we wrote it down? So that means this whole number is to the left of the decimal point. So I'm just going to write negative 2 and put a decimal point. Whenever you see a whole number, you don't need to change this to an improper fraction and take the long way around it. This means that you have negative 2 and part of something. So I'm going to put that in the whole number area, which is to the left of the decimal point. Now 1/4, I was talking about fourths, and 1/4 is equivalent to 0.25, right? If you know that, then you're just going to write your 2/5 and call it a day. You'll be done with that. If you don't know those equivalencies, which right now you're probably kicking yourself saying, oh, I need to memorize those. It's never too late to memorize them, so go for it. But if you didn't know that, then what we would do is we could, number 2, write the fraction as an equivalent fraction with the denominator and make it, so I could try to make this 10, 100, 1,000, and so on. I'm not going to go through both ways. I'm just going to focus on number 3. So if you can't do number 2 and you're not aware of number 2, I'd be happy to show you how to do that at lunchtime, but I'm just going to focus on one aspect of it now. Otherwise, the notes would take forever, and they're already taking too long. So 1/4. 1 is the numerator, 4 is the denominator. I'm going to use long division. So what you need to know is 1 divided by 4 means that 1 is on the inside, 4 is on the outside. This is showing that I want to divide 1 up. So up here, yes, it's numerator divided by denominator if I wrote out this way. This would mean if I was writing it in long division form, the numerator goes on the inside, the denominator goes on the outside. Alright, so this shows 1 being divided by 4. 4 doesn't go into 1. That's why we have a decimal, right? I don't want to change the value of this, so I'm going to put a decimal point here and a 0 afterwards, because isn't 1.0 worth the same as 1? So I'm putting a decimal here. I didn't change the value. I just made it so that I can actually divide. Bring your decimal point up. 4 doesn't go into 1, but it goes into 10. It goes into 10 twice. 4 times 2 is 8. We subtract. 10 minus 8 is 2. I still have a remainder, so that means I'm going to keep on going. I'll add another 0 because that doesn't change the value of anything, and drop it down. 4 goes into 20 5 times. 4 times 5 is 20. Subtract. Once you get your 0, then we know that we're done. So that's another way to get 0.25 if you didn't know that benchmark fraction. All right, next I have 5/11. Okay, there's not a whole number, so I'm not going to worry about that. This probably isn't one of the benchmark ones that you would know. So let's go straight to the long division. This means I'm taking 5, and 5 is being divided by 11. So 5 goes on the inside. 11 won't go into 5. So I'm going to put that decimal point after, so it's still worth 5. I'm still dividing 11 into 5, but I need some extra zeros to work with. So I'm going to bring my decimal point up. 11 goes into 50. Well, I know that 11 times 5 is 55, and it's too big, so it must be 4. And 11 times 4 is 44. We're going to subtract, and 50 minus 44 is 6. Still have a remainder, so I'm going to keep adding zeros until I can get rid of it or it repeats. We'll bring it down. 11 goes into 60. Well, 11 times 6 is 66, so that's too high. It must be 5. 11 times 5 is 55. And we subtract. 60 minus 55 is 5. I still have a remainder, so I'm going to add a 0, drop it down. 11 goes into 50. How many times? 4 times. 11 times 4 is 44. We subtract. Get 6. Drop down another 0. And 11 goes into 65 times. Do you see what's happening here? It's going to keep happening, isn't it? So when things keep happening like that, we can use the bar to show that this is a repeating decimal. So I'm not going to write more than 145 here. I'm going to write 0.45, and I'm going to put a bar over the 4 and the 5. You can put a 0 in front of the decimal point if you want. It's not a requirement. You don't have to. Sometimes it'll be written like this. Sometimes it'll be written without it. The value is the same. All right, next one. I have a -6/5. First off, I don't see that there's a whole number. I see there's a negative sign, though. So I'm going to write that down right away, so at the end I know that my total answer needs to be negative. That's one little way you can lose points, and I don't want you to. So bring the negative. Numerator divided by denominator. That's how we do it. So that means that the 6 is on the inside, the 5 is on the outside. This shows that the 6 is what's being divided by the 5. So top goes inside, bottom goes outside. 5 does go into 6. It goes into 6 once. And 5 times 1 is 5, and we subtract, and 6 minus 5 is 1. I have a remainder, so that means we're not done. If you're going to put a 0 here, we've now changed it to 60 divided by 5. Make sure when you add your zeros that you put the decimal point so that it's still 5 into 6. We'll bring that up. I'm going to drop down that 0. 5 goes into 10 twice. 5 times 2 is 10. And now we have no remainder. So we get 1.2. Bring over that negative sign, and you're done. And this makes sense that I have a whole number here, because if you have 6 out of 5, it means you have more than one whole amount, right? 5 out of 5 means one whole. So 6 out of 5 means a little bit more than 1. Or in this case, a little bit less, I guess, because it's a negative value. All right, last one. I know, yay. Okay, so there is a whole number here. I'm going to write that with a decimal point after it. And now we need to change 5/27. I'm guessing you don't have 5/27 memorized. Neither do I, so let's work through it together. 5/27 means the 5 is being divided by 27. Yep. So 27 doesn't go into 5. I'm going to add my decimal point there. 27 does go into 50. It doesn't quite go into it twice, though, because that would be over 50. 25 would go into 50 twice. So just one time. And now we're going to subtract. Maybe you're doing some borrowing here. Maybe you just know off the top of your head that it's 23. And I have a remainder, so I'm going to add that 0 there. 27 into 230. Well, I'm going to use some estimation here. 27 is pretty close to 25. And I know that 25 would go into 104 times. And 25 would go into 208 times then, right? This is a little bit more than 25, so I'm going to guess that 27 goes into 238 times. So to figure that out, I'm not going to write it over here just yet, because I'm using pen. I'm going to take 27 times 8 and see how close I am. 7 times 8 is 56, and 8 times 2 is 16, and when you take 16 plus 5, that's 216. I think we guessed right, because if I threw another 27 on there, it would be too big, so I'm going to put the 8 there. And we just figured out that 27 times 8 is 216. When you subtract those, 10 minus 6 is 4, 2 minus 1 is 1. I still have a remainder. I know. Ugh. So let's drop down another 0 there. 27 into 140. Okay, again, if I'm rounding 27 to 25, I know that 25 goes into 100 4 times, and I'll have another 25. So that would be 5 times, would give me 125, and since we rounded up, I think it'll go into that about 5 times. To check it out, I'm going to take 27 times 5 and see how close to 140 I am. 7 times 5 is 35, 5 times 2 is 10, plus 3 is 13. Ooh, we are pretty close. I don't think I can get any closer. So that's 5, and we already figured out that's 135. We subtract, and we get 5. Alright, so now I'm going to bring down another 0, and I'm hoping that you're seeing that. This is the very first thing that we did, right? 50, I have another 50. That means that this 0.185 is going to keep happening, because I'm going to have this 50, and this will repeat, and this will repeat, and this will repeat. We can keep going on, because it's already been 22 minutes, and I'm sure you totally feel like it. Or we can just say, hey, I know that's going to repeat, so I'm going to put a repeating bar over all 3 of those digits to get my final answer. And there's no negative sign, so we didn't forget it. And now you are done. Go relax.